Hello guys, today we are going to discuss about heap. Heap data structure in DSA. Heap data structure is our most important data structure in DSA. Today we are going to discuss heap basics, max heap, min heap, extract min, extract max, build heap, and sorting in heap, and many more things which are essential to understand the heap. Firstly, we will cover the heap basic. This is a full complete lecture on heap, so don't worry about heap data structure. This video lecture comes by part, so go through this video carefully. So not wasting the time, starting the heap data structure. So coming to the first page, heap basics. And one question is wondering in your mind, what is heap? Okay, a binary heap. We can say a heap into a binary heap also. A binary heap is a complete binary tree which is used to store data efficiently to get the max or min element based on its structure. A binary tree is a complete binary tree. If you don't know the complete binary tree, please go in the comment section where I pinned a link to the video of the complete binary tree where I explain the complete binary tree briefly and completely. Okay, I explain the complete binary tree completely. Okay, this is basic exercise of this. Through this lecture, we are going to insert and delete. Firstly, we are going to discuss insert in a heap, inserting an element in a heap, and deleting an element in the heap. So now, what is heap? Actually, we can say if we want to understand heap in a layman language, what we can say that heap is used to implement priority queue. There are two types of heap: min heap and max heap and min heap. Okay. Now, what do you mean by max heap and what do you mean by min heap? As you can see from the diagram, I'm coming to the point. A heap. You can understand a heap by a tree, by a complete binary tree, by a complete binary tree. Okay, this is complete binary tree. This is complete binary tree, and this is also a complete binary tree. Now, what is the heap? Heap is a data structure. I am telling that heap is a data structure in which min heap and max heap are its two types. So now we are going to discuss what is min heap. As you can see, this is a tree, complete binary tree. If we closely look at the root of every left or right children of, then we see a specific property that root is always smaller than its children's. If we look at again repeating it, root is always smaller than its left or right children. If we see in this tree, condition 10, its left children is 15, its right children is 30, and we know that 10 is more than 15 or 30. And coming back to 15, if we come back to 15, then we see that its left child is 40 and right child is 50, and we know that 40 is greater than 15, so 15 is less than 14, 50, and 30. If we come to 30, 30 is left child is 100 and its right child is 40, so 30 is smaller be among being these three elements. Okay, so this is a mini. Okay, now what is max heap? If you closely look at the this example on the right side, it's just we can say it's a reverse of mini. Not practically, but theoretically, we can say that is a reverse of mini. How? Uh, in the max heap, the root element is always greater than its left children or right children. Again, repeating it, in the max heap, the root is always greater than its left children or right children. Okay, as you can see from the example 15, its left children is 5 and his right children is 10, and we can clearly see that 15 is greater than 5 and 10. If we come to 5 and 5, the left children of 5 is 2 and the right children of 5 is 4. So the 5 is greater than 2 and 4, and if we consider 10, the 10 is always also greater than 3. Okay, so this is maxi and mini, the basic concept of maxi and remember one thing: when you are dealing with heap, when you are dealing with heap is always given to you in the question in the form of array. Heap is always given to you in the question in the form of array, because I will tell you, suppose this heap, I will insert this heap in the array. How I can insert this heap in the array? Because there's an interesting property of heap. When we insert into this array, we got an interesting property of the heap. I will tell you. Firstly, I have to insert this heap into this mini. This is a mini and this is a maxi. Okay, into the array. Okay, so inserting it, as you can see that one photo is coming on your screen. That is this. This is an interesting property when we insert a heap into the array. What is this? Look, we can know when we insert the heap into the array, we can know the root element, left child, right child of any given specific node. How? Let's see it. This, this, this. Suppose I will suppose firstly I have to give the indexes to the arrays. This is the indexes to the arrays. Array 1 represents the mini, array 2 represent the maxi. Okay, now as we can see, suppose it is represent maxi. Suppose we have to find the root of this 20. Okay, in the mini array, what is the index of the 20? The index of 20 is 1. So if we look at it, these formulas, we have to find the root. So returns the root, returns the parent node. Okay, parent means roots. Okay, so if we apply this formula, suppose what is this formula? Array. First, let me write array I minus 1. Oh god, 1 minute. Yeah, if we put I is 1 here, I is 1. Okay, so if we put I in this formula, I is 1, 1 minus 1, it's come out to be 0, and 0 divided by 2 is again 0. And if we go to the array of index 0, then we find 10. Is it 10 is the root of this 20? Yeah, this true. Not worry, if you don't find it's true, I will again give you another example. Suppose we have to find root of this. The root of this is also 10. So let me check what is the index of the 10 in the many of the array. The index of the 100, sorry, 100 is 3. It's 2. Sorry, it has only 4 elements. So 1 minute, I have given wrong indexes. Sorry for that. So the index of the 100 is 2. So if I put 2 in this formula, as if I replace I with 2 in this formula, I will get 2 minus 1 is 1, and 1 divided by 2, and 1 divided by 2 is 0. And if I go to the index 0 of this array 1 of mini, I will again get 10. So it holds true. Okay, that again it holds true, sir. It holds true for the mini. Can it also store holds true for the maxi? Let's check. Suppose if I want to know the root of this, parent of this, I know this parent of is 100, sorry 10. So let me check first the index of this three element in the maxi array. The index of this element is 5, as you can see here, 5. Okay, now I want to check the root of this. So if I go to like this, if I put as a replace I as a 5 in this formula, I will get 5 minus 1 divided by 2, that is 2. What is the index, what the value, what is the element of the index? 2 is 10. Yeah, it is correct. As usual, you can also check written left side and right side. It's always holds true for a specific value of I, until unless I, that is 2 into this, this also belongs to array, this also belongs to array, and this also belongs to array. Means it means I should be belongs to the element, should be less than n, in which we are telling. Okay, and this is also like that. Like that. As I am telling that 2 into I plus 1 should be belongs to n in the range of array, in the size of the array. Suppose I put I as 5, as you know that this is an index of 5, the index of array. So I, if I will put 5, then it will, the answer will come out, so 11, and there's no 11th element in the array, so it is out of bound, it will give this segmentation error. So first we have to check this condition also. Okay, so there's an interesting fact about heap when we convert heap into the array. Now let's move to the inserting and deleting of an element from a heap. Let's come to the section of inserting an element in the heap. Suppose we have given this max heap and we want to insert the 15 element in it. The value of the element is 15, or we can say the value of the node is 15. So we have to insert this node into this heap. So how we can insert it? First, think. Uh, Please pause the video and develop the hint for that. And remember, while you are inserting the elements, and I have already told you that it's a max heap. So while inserting the element, the properties of max heap doesn't void. If you void the max heap property, then it's not correct answer. So while inserting elements, please remember that you have to not void max heap property. You have to insert element in such a way that a max heap property of this heap will not void. Okay, for hint, I will give you a hint. Uh, as I have already said you that you have to consider heap as an array. Now convert these heap into the array. Now rearrange the array in such a way that it will build a maxi when we insert this 15 element into the array. Okay. Now please pause the video and start thinking about that. If you can't able to develop the hint, so there's a solution for it. As you have we have to insert 15. So let's come to the process section of insertion, you can say. Okay, now that insert the new element and the 10. What we have to do, firstly, suppose that we have to given, we have given a binary. What we will do, so firstly we will convert into the array format. Okay, what we will do, we will convert this heap into the array format. Okay, I will convert I convert this into this array. Now, firstly, what we have to do, we have to calculate the size of this array. The size of this array or heap is same, so it is firstly this 5. Now, what we have to do, we have to insert the new element at the end. It means that we have to insert the element at the last of the array. That is 15. We insert it and increase the size by 1. Increase the size by 1. Now think what we will do. So not to void the maxi property, we have to check what is the maxi property. That the root of a node should be greater than its children, so left or right children. Okay. So now we have installed it is in the right, in the end of this heap, and I have already told you that you can know parent, left, and right child of a specific node in a heap if it is lies in the heap. Okay, now as we know that, so to check it is it while after inserting the element it follows the max heap or not, what we will do, we will compare it with its root. If it is, if it is smaller than the root, then it's okay. If it is the greater than the root, then it is not okay. We have to swap them, we have to swap root with the this element. Okay, how? Let's see. As you can see from this step 2, heapify, 15 is more than its parent 3, so we swap them. Okay, now we again check it. Now the 15, if it all, now we check 15 that it is greater or smaller than its updated parent. Okay, now if we check its updated parent is 2, previously the parent 15 is 3, Now after swapping them, its current parent is 10. So if it is smaller or greater than 10, we can check it. Yeah, it is greater. So we swap them again to 10 and 15. So heap will form like this. Okay. Now it is a correct heap because we swap every condition that violates maxi. Okay. Now try to build a code yourself and post, and don't forget to post in the comment section. As you post in the comment section, it gives motivation that you are listening, and please give valuable guidance in the comment section. How will I improve, how will I improve that, in the teaching section, in the voice section, in the expression section, I will improve. Tell me the area of improvement, and I definitely guarantee that I will improve. So coming to the code part now, uh, firstly try code yourself in an any editor. Like you can find this question in GFG platform, lead code platform, and others, and you can also try your VS Code editor. Okay, so try it on your own, then I will tell you the code. So this is the code. So what is coming on the screen? Sorry for interference between you and the code. Oh, okay, of the voice. Let's come to the code section. Now I have created a function void insert which takes an argument of the value to be inserted x. Now how we will insert, what I tell, I convert this into the code. Firstly I increase the size of the element, sorry, array, then I insert the element into the array, then I will check if it is a checking condition, it is a checking condition. Okay, if my the element to, firstly I have to take the index of the element which I insert in the array, which is size minus 1, then I will check with this parent if it is smaller than its parent or not. If it is smaller, then we don't swap them. If it is greater, then we swap them and update the I. Then if it's again check with this new parent, if it again doesn't violate the max equal property, then you again swap them. Don't worry, it's we we simple coming out from this function. Enough, that's the enough. So we will now, in the next video we will discuss the delete section. Okay, so hope you like this video, enjoy this video, and please like, comment and share this video, and thank you.